Hello YouTubers, welcome to my YouTube channel. Uncle Pythagoras is welcoming you. Today we are going to do Theorem 5. We have done Theorem 1, we have proved Theorem 1, we have proved Theorem 2, we have proved Theorem 3 and Theorem 4. Now we have to prove Theorem 5. Remember matrix and grade 11. This is for grade 12 and 11. Both grades are applicable in this one. This is cyclic geometry. We are going to prove the theorem that says the opposite angles of a cyclic quadrilaterals are supplementary, which means they add up to 180 degrees. That means opposite angles of a cyclic quadrilateral. Right, we are given A, B, C, and D are points that lie on the circumference of the circle. A, B, C, D is a cyclic quadrilaterals. We are required to prove that angle A plus angle C is equal to 180. And we must prove that B plus D is 180 degrees. Right, for our proof, this is a triangle, this is an angle that we have. This is A, C, D and B. For proof, we are going to tell the marker that we are going to construct. Construction, we must join OA and OC. As we are telling them, we are going to do the same. This is OA, join them by construction. Right, if we have separated, we can come and say this is O1, this is O2. Remember grade 11 and 12, we have proved that theorems from 1 up to 4. All these theorems, they borrow to each other. So somehow we are going to borrow from the previous theorems that we have proved. That means they are applicable. They apply to one another. Now, we start by saying statement and reason. So we are in this second. In this second, if we have constructed OA and OC, therefore, we can say O1. See this angle O1. Angle O1 is equals to 2 angle D. The reason for that, we have proved in the previous theorems that angle at the center is equal to 2 times angle at the circumference. Even when you have to come and apply in the radii of this, when we are going to prove that this angle is equals to twice that angle. This is the angle at the circumference, and this is the angle at the center. Therefore, we come and say O2, this one at the top, O2 is equals to 2 times B. The same reason is angle at the center equals to 2 times angle at the circumference. Right. Therefore, we can combine O1 and O2. O1 and O2 is equals to 2 angle D plus 2 angle B. But O1 plus O2 is equals to 360 degrees. You see, O1 and O2 is equals to 360 degrees. This is a revolution. So you give the reason S. This is the reason for that statement. Angle at a point. If you don't want to say this reason, you can say revolution. Revolution. Since this is a revolution, we can now say because O1 and O2 is equals to 360 and O1 and O2 are at the center, then we can say that 2 angle D plus 2 angle B is equals to 360 degrees. What is the reason for that? Because 2 angle D plus 2 angle B, they are both equals to O1 and O2. And we said that O1 and O2 is 360, which is revolution. That means that 2 of D plus B, you took out the common factor of 2 is equals to 360 degrees. Therefore, D plus B is 360 degrees divided by 2, which is 180 degrees. We have proven. We were required to prove that angle A plus C is equals to 180 degrees and angle B plus D is equals to 180 degrees. Now this is proven, so you can prove that this is what we have proved. Now we are left with this one. This one you can do the same. You can say similarly, construct, join OB and OD. This is one part we have proven. Then we come to prove that angle D, angle A plus angle C is equals to 180 degrees. Now we start by construction. Now we're going to use this one. This was from this one. Then we have to prove that A plus C is 180. Construction, we join OB and OD. Let's join them. This is OD. We have joined it. We join this one as well. OB. Such that we have O1 and O2. Right, we write your statement and you write your reason. Then we start by saying O1 is equals to 2NLC. The reason for that is NL at the center is equals to 2 times the NL at the circumference. We come to this NL, NLO2 is equals to 2NLA. Same reason, NL at the center is equals to NL at the circumference. Then we say O1 plus O2. Together these two NL, they are equals to 360 degrees. The reason for that is revolution. Remember, we said if you don't want to say revolution, just say NLs at the point. The NL at the point, this is what we mean. This is your point. When you go all around from where you started to where you end, you have completed a 360 degrees. This is what we are referring to. Now, we can say that O1 plus O2 is equals to 2 NLA plus 2 NLC. Then we say take out the common factor, it's 2A plus C is equals to 360, which is O1 plus O2. Just a matter of taking this on the left hand side and O1 and O2 on the right hand side. But we know that O1 and O2 is 360, so you say A plus C. 2 of them is equals to 360. The reason that you have given as a revolution. Therefore, you divide here by 2, divide by 2, divide by 2. You have A plus C is equals to 180 degrees. This grade 12 and grade 11, if you take this angle, you add it to that angle, they must supplement. Supplement means 108. When you add angle D and angle B, you get 180 as much as when you add angle A and angle C. You must get A 108. That means A, B, C, and D are cyclic quadrilaterals. This is how you prove it, and then you will come to apply it in the problems that will be given to you so that you can apply and show them that you understand geometry from the theorems. If you don't understand theorem 1, 2, 3, and 4, we have done it. It was covered in the previous videos. Just go back and check from the Angle Pythagoras YouTube page. You will see that we have covered how do you apply, how do you prove theorem 1, theorem 2, 3, and 4. This is one of the theorems that they like to ask In fact, all of them, but this one is the most common. They want you to prove that angle B plus D is 180 degrees and angle A plus C is 180 degrees. That is a cyclic quadrilaterals. Thank you very much. I will see you in the next video where we have to prove the next theorem, theorem 6. Don't forget to like and subscribe. Watch all the video until the end. Do not skip the advertisement. Thank you very much. Uncle Pythagoras, thank you very much.